Hello everyone, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. I have been teaching maths for past 14 years to the students preparing for JEE Mains Advanced, Olympiads and ISI CMI. In these sessions, I am bringing one or two subtopics where I am giving you short tricks, certain alternate ideas which will help you solving questions easily. You will feel more confident while solving questions, especially in JEE Advanced type questions. I like to mention about Daksh, who got All India rank 15 in 2025. He was student of 𝒉𝒐 22 to 25 and I was teaching him for 3 years. He got full 120 marks out of 120 in JEE Advanced 25 in maths. That's a rare feat by any student. Okay, through these sessions, in fact in these sessions I am sharing with you the same ideas which we were sharing, which we were discussing in the class. In fact, I got many ideas while having discussion with Daksh only. So objective here is to repeat that performance which Daksh gave in 2025 and now it's your turn, you give in 26-27. One more thing bachcho, as I am getting the very good response through the chats and otherwise, so I am feeling very happy. Otherwise my plan was not to continue these sessions, as these sessions are extra work for me, as I can say, because those students who will be appearing, they are still with me and my commitment with them cannot be, I cannot lower my commitment to those students. But as I am getting the good response, I am feeling that I will continue these sessions, as Shimon sir has promised with you and Shimon sir has talked with me. So I think we will continue these sessions for long, I am sure, and keep giving me your feedback, and I think we will be having a long association through these sessions. In today's session I will be talking about the topic that is areas without use of integration. What is that? Actually, normally we find area used with the help of integration. I think that is how areas are found in our syllabus. Okay, it is not the finding the area of circle or rectangle like that, but the questions, the kind of questions JEE is asking, it is possible that we can find areas without use of integration if we remember 1 or 2 or hardly 3 results, because most of the time they are asking area from parabola, ellipse, circle or sine, cos. So if you can remember few of the results, and which is very easy to remember, and you will see the utility of these results in questions of PYQ, which I will show you in this session only. So that will make questions of area without help of integration. Integration is still there, we can still use integration if you feel like, but I will be sharing few idea how without integration also you can solve those questions, and it will make your questions faster, it will make your solving faster. In the end I will be giving you one more concept, that is minimum area concept. Okay, so as it will come I will talk about this. So let's start. So my first concept here is, which I call as to-do's theorem. It is related to parabola. What is to-do's theorem? Please see. Yeah. So whenever we are asked to find area related to parabola, okay, and we can find out certain portion of that area, or maybe this is the area they are asking, where one chord AB is meeting the parabola, okay, and this is the tangent at vertex, this is the tangent at vertex. Now if you drop perpendiculars from A and B to this tangent at vertex, let's call these points as M and N, this distance between M and N I can call as the I can call this as the projection of AB over tangent at vertex. So D is what? Projection of the length AB over this length over the tangent at vertex. Okay, then this area bounded between parabola and this AB is directly equal to D cube upon 6L. Okay, where L is the length of latus rectum. We know y square is equal to 4ax equation, where 4a is equal to latus rectum. So this L is equal to length of latus rectum. So if we can find, suppose this parabola is along is opened along x-axis or y-axis. So this projection is nothing but the difference of y coordinates or x coordinates. So you can find d directly from there, and latest rectum we can find from the equation. So you will get this area directly without doing any integration. The proof of this I have given in the session notes, so I am skipping that proof here. Okay, so this is what I was talking about. Area between parabola and its chord is given by dq upon 6l, where d is the length of projection of the chord on tangent at vertex, and this l is the I think it is hidden, but this l is the length of latus rectum, Okay, now few more proof I am leaving. Okay, now few more ideas related to parabola only, and the next one is, suppose instead of your chord AB intersecting parabola at some slant angle, if it is intersecting the axis at 90 degree, okay, and let's say this chord is AB meeting this as, let's say, C, okay, this is O, and if we are looking for this area, if we are looking for the area bounded between parabola, the chord AC, portion of chord AC you can say, and its axis, okay, then this area is actually I am making one rectangle with the help of tangent at vertex and this AC, and from A I am dropping a perpendicular here, let's say M, okay. Then please see this rectangle, I think we can find the area of rectangle easily. Then this area is actually 2 upon 3 times the area of rectangle OCAM, rectangle OCAM. In fact, if you want the complete area, this also if you want, so if you are looking for the area AOB bounded between parabola and AB, in that case you are supposed to take this rectangle, okay. Here the important thing is your area, this chord has to be perpendicular to the axis, okay, and one side of this bounded area has to be axis, okay. Then it will become 2/3 of the area of this rectangle ACOM, okay. I have summarized it here, please see. So area of the region OA along axis of parabola, actually along axis of parabola, sorry, it was correct, along the parabola is 2/3 of the area of rectangle OMAN, actually OMAN, okay, where O is the vertex, OM is along axis of parabola. If O is origin, now that's very important, suppose your parabola is just y square is equal to 4ax, okay, then O will be origin, which is the vertex of the parabola. Then this area of the rectangle is nothing but alpha into beta, because this side will be alpha, this side will be beta, so your area will be directly 2 upon 3 of alpha beta, okay. So this is also important, although this can be found using to-do's theorem, but I will like you to remember it separately, 2/3. Now if it is 2/3, then this thing, okay, that is the remaining portion of this rectangle has to be 1/3, isn't it, which I am showing it here. So that will be 1/3 of the same rectangle, okay. The important thing here is this OM has to be along axis, O is vertex, okay, and AM is perpendicular to axis. And if again same thing, if it is origin and this is along x-axis or y-axis, then alpha into beta will be the area of the rectangle, and this area will be just 1/3 of alpha beta, okay. One more thing, suppose you are looking for this area where O joined with A, okay, this small portion here, this small portion, this I am looking for, then this will be how much? I think it should be 2/3 minus 1/3, okay. It should be it should be 1/2, it should be 1/2 minus 1 upon 3. In fact 2/3 minus 1/2 also you can do. You can look it from this angle, where 2/3 subtracted 1/2, because diagonal of this rectangle will be dividing the area into 2 equal parts, so 2/3 minus half, or this will be half minus 1/3, because this is 1/3 here. So this portion here comes out to be, if you solve it, this comes out to be 1/6 of this area of rectangle. And again same thing, if this is along x-axis, along y-axis, then it will be 1/6 of alpha beta only. Actually in most of the questions which are given to us in JEE Mains or Advanced, we are mostly given standard parabola or maybe shifted parabola where axis will be along x-axis or y-axis. So this area of rectangle can be found easily just by help of the x coordinate, y coordinate. Okay. Now before I come to the questions, there I will like to mention the area related to circle and ellipse also. Now what is this thing? I think this we have done in our junior classes like 9th grade, 10th grade, that if we have to find the area of this sector, if I have to find the area of this sector, okay, this sector, if you have to find, it is just half theta into r square. If you do not know, please remember it, it's very important. And you can see if theta becomes complete 2 pi, this gives you the complete area, that is pi r square. So here this sector area is 1/2 theta r square. I think this you know it already. Okay. Then if we are looking for the area of this segment, okay, this OAB, it was a sector. Now if you join A with B, so this portion towards the circle, that is the segment. Okay. Now this can be found using the area of sector, area of the sector, that will be 1/2 into theta into r square, that is OACB, and then you have to subtract the area of this triangle, that will be 1/2 into r into sine theta. So if you solve it, you will be getting this area directly. So suppose somewhere you are getting this kind of area, you don't have to use the limits, you can directly get area using this thing. Once again, it is not that you are not supposed to do the integration now. It is only that if you find this kind of situation, you use this kind of trick to get your area. So half theta minus sine theta into r square. In fact, we can get areas between two parallel chords also using the same thing. Now suppose one chord is making angle theta 1, another is making theta 2, then this area will be just the difference of the two things, and you can find this area. I will not say you remember it, I will only say you just understand the concept behind finding this area, and then after that finding this area will be easy task. Do not remember it. I have written this just for the reference, but not as a formula. Okay. Similarly, if these parallel chords are on the opposite side of the center, then it can be slightly different. You can solve it by finding these areas as I have told you already, and then subtract from the area of the circle, you will get this thing. Okay. Now ellipse. Circle was, I think, easy, you might have done it otherwise also, but for ellipse I like to tell you one similarity between ellipse and circle. You can think of ellipse being, compressed version of circle in one dimension, maybe along y-axis or along x-axis, other dimension being remain intact, you can say. So you can see, suppose this was the auxiliary circle of this ellipse, okay, and we know if this is A, okay, so auxiliary circle will have the equation x square plus y square is equal to a square. I am assuming this is x-axis, this is y-axis, okay, and suppose your semi minor axis is b, okay. So you can see that this dimension, that is along y-axis, has been compressed from A to B. So what will be the impact of this thing? Your area of circle is pi a square, okay, because only one dimension is compressed. So for area of ellipse, we can get the area by doing multiplication with b upon a. So pi a square multiplied with b upon a will give you the area of ellipse. Okay, why I am telling you this thing? Because this is something, I think this, if you can remember, you will be now able to see that all corresponding areas of ellipse now can be connected with its auxiliary circle. For example, if I have to find the area of this sector of ellipse OAB, okay, so what I will do, I will take a corresponding point to B on the circle, let us say C, and you know it, how B to C we reach. Okay, so if B is having coordinate A cos theta comma B sin theta, the corresponding point on auxiliary circle will be a cos theta comma a sin theta. Now we can find the area of the sector OAC directly, because this angle will be theta. I think that area will be pi, not pi, that area will be theta into a square by 2. Okay, but if you are looking for this area, so from OAC to OAB, my area will be directly just multiply this by, as I was telling you, B upon A. If you multiply by B upon A, you will get this area which is shaded portion here in the diagram. Okay, so whenever you have to find certain area in ellipse, okay, take those points to the auxiliary circle, and whatever area, corresponding area you get on that auxiliary circle, multiply it by B upon A, you will get area on ellipse. No need to divide in two parts taking the limits, you can find it directly. Okay, so B upon A times the area of the sector AOC of auxiliary circle. Okay, similarly, if you are looking for area of sector between AOB, where A or B, they are not along your major axis. Okay, this can also be done with the help of auxiliary circle easily. You just from A to C reach your point on auxiliary circle, from B to D you get a point on the auxiliary circle. Okay, then whatever area of COD you are having, just multiply it by B upon A, you will get the corresponding area on your ellipse. Here also there is no need to do any integration. Okay, half theta AB, and remember this theta is not the angle that you are getting here on ellipse, rather this theta has to be this angle that is there on the auxiliary circle, because in the circle whatever physical angle you are getting on your diagram, that is used to find the area. But in case of ellipse, this angle will be skewed because of transformation of C and D along certain lines. So this theta 2 minus theta 1, if if you are taking your angle from your major axis, so that physical angle may not be equal to theta. So the angle theta is always taken from your auxiliary circle. It was there, it was here also. You can see the theta which I was talking about, it was the angle of your auxiliary circle, that was the theta. Okay. Now similarly, you can find the area of elliptical segment. You just find the area on the circle, and then from this to this, if you go, you just have to multiply by B upon A. I told you how this area is found in circle, so you just have to multiply by B upon A. Okay, theta will be theta 2 minus theta 1 should be taken from corresponding position on auxiliary circle. It is not physical angle on ellipse, it is a physical angle on corresponding auxiliary circle, or you can say parametric angle. Yeah, parametric angle also you can take. Okay, but please take care of it that you are choosing the value which will be there on the diagram in the auxiliary circle. That is important. Okay, so any area related to ellipse is always B upon A into corresponding area on its auxiliary circle. Okay, now I have taken few questions to show how you will use those to-do's theorem, 2/3, 1/3 thing, or maybe some ellipse thing. So let's see this question. This is not a PYQ, I have taken it from my side. Here they are saying the area of a region given by A equal to x comma y such that y is between x square and maximum of x plus 2 and 4 minus 3x. So how such kind of questions are given? On the one side you are having this standard parabola y is equal to x square. So I think that will be upward parabola, that is my y axis, that is my x axis. Okay, now maximum of these two things. Okay, so let me use a different color here. So y equal to x plus 2, let's first make. So y is equal to x plus 2 means it will be a line having slope 1 and its y intercept would be 2, x intercept will be minus 2 here. Okay, so that is y is equal to x plus 2. Similarly, y is equal to 4 minus 3x if I draw. If you put x is equal to 0, it will be having 4 here and it will be, I think, going like this. Okay, and yeah, this parabola will be intersected by this line somewhere here. Now which area we are looking for? Let me make this area using this color maybe. Okay, so what area we are looking for? We are looking for y between maximum of these two lines. Maximum means from this point to this point of intersection. I think we will be using this line, which is y equal to, yeah, it is visible, 4 minus 3x, and then this line. Okay, and y between this and x square. So below it is x square like this. Okay. Now otherwise, if you do this question, you may be dividing, you may be breaking your limits from this point to this point and this point to this point. It can be done. Okay, and also let us first find out the points. These points, I think this point is coming out to be y is equal to x plus 2 and y is equal to x square. If you solve, so x square is equal to x plus 2. I think you can by observation also say that x is equal to 2 will be the x coordinate, and if you put x is equal to 2, y will be 4. So that is the point of intersection. In fact, there will be one more point of intersection, but that is of no use for us. It will be having negative x coordinate, which can be found using this quadratic. Similarly, for this point, I will need this 4 minus 3x to equal to x square. Okay, so that is x square plus 3x minus 4 equal to 0. Okay, so what are the roots here? I think x is equal to minus 1 is satisfying. No, it is not. X is equal to 1 is satisfying. So this point would have been x is equal to 1, but I need a point with negative x coordinate. Product of roots is minus 4, and by observation one root is 1. So I think I can say the other root will be minus 4 in terms of x. So y coordinate will be 16. Okay, this point is the intersection of these two lines. So if you solve them, x plus 2 equal to 4 minus 3x, we will be getting x coordinate as half and y coordinate as 5 by 2. Okay, so normally what we will be doing, we will be doing the integration from minus 4 to 1 by 2 and then 1 by 2 to 2 and taking difference of this function with this parabola, then this function with this parabola. That can be done definitely, but I like to tell you a different method. Please see. Here what I will do, I will join this point to this point. Okay, and now I think you can understand this point, let's say A, this point is let's say B, and this is vertex O. So this parabolic area AOB we can find directly by To-Do's theorem. Area AOB can be found directly by To-Do's theorem, that is d cube upon 6l. Okay, d cube means the projection on x axis, which is its tangent at vertex. So it will be just difference of x coordinates. So 2 here minus 4 here, so it will be 6 cube, and latest rectum. So for y square is equal to, for y equal to x square, latest rectum is just 1. So L will be equal to 1 here. You know, x square is equal to 4ay. If you compare, the 4a thing is 1. So here your area is 36. Now from this area, I think we need to subtract the area of this triangle. Okay, and this area of triangle can be found using determinant or stairs method, and if you subtract it from 36, you will get your desired area. Okay, I'm writing the answer directly because I think this area of a triangle can be found easily. There is no problem in that. I think this area comes out to be area of triangle. I call this point as DABC actually. So triangle ABC will be equal to, after calculation, it is 27 by 2. Okay, so the final answer for this should be 36 minus 27 by 2. Okay, so that is the answer. 36 into 2 72, 72 minus 27 is 45, 45 by 2 is equal to 2k upon 15. So the value of k comes out to be, you can find out, I think that's not a big deal. Okay, so moving to the another question. Yeah, this is done. This question, find the area enclosed by parabola and tangent to it at 2, 3 and axis. This question I think is from very old PYQ, so I have not mentioned it here, but see how this can be found directly by To-Do's theorem. So we are given parabola that is, right opening, but its vertex is at 1 comma 2, 1 comma 2. So my x-axis and y-axis should be something like this. X-axis will be here, y-axis will be here. Okay, and that point is 1 comma 2. In fact, if I put y equal to 0, this point will be having x coordinate as 5, 5 comma 0. Okay, now this is 1 comma 2. Let me write it 1 comma 2. So 2 comma 3, where tangent is to be drawn, will be somewhere here. Okay, so if you draw the tangent, it will go like this. It will meet the this point is, let's say, A, this point is, let's say, B, this point is, let's say, C. Okay, so the area which we are looking for is bounded by tangent at 2 comma 3 and x-axis and parabola. Okay, so I think we are looking for this area. We are looking for this area. Okay, so here what we are going to do, we will be finding the area of this triangle, sorry, ABC, that is just half base into height, if we can find the coordinate of C. And for that you need to write the tangent equation at A, that you have to do it. There is no shortcut for that. So tangent at 2 comma 3, you just have to differentiate it to get the slope of tangent. I think differentiation would be 2 into y minus 2 into dy upon dx. Okay, on the right hand side it is 1. So at 2 comma 3, put y is equal to 1, we will be getting dy upon dx is equal to half. So the slope of tangent at this point would be 1 by 2, sorry, 1 by 2, 1 by 2. So the equation becomes, y minus 3 is equal to half into x minus 2. I think if you solve it, you get y 2y minus x is equal to, because slope will be half, and 2 comma 3, so 4 minus 3 is 1. I think this is what we are getting. Now here if you put x coordinate, y coordinate 0, I think x coordinate is coming out to be minus 1. So C point will be minus 1 comma 0. Okay, so I think all is now set. We can use To-Do's theorem, we can find area of triangle, and then we will be able to find this area, required area. I think this 2y, okay. So 2 into 3, 6, 6 minus 2, 4. I think it will be 4. So that will be minus 4. Okay. So this area of triangle would be half base, that is 5 plus 4, 9, into height, that is 3. Okay. So that is 27 by 2, 13.5. And this area of this A, let me call this as a vertex, that's V. So AVB, this area we can find by To-Do's theorem, and that should be how much? You just have to take the projection on tangent at vertex, and that will be nothing but the difference of y coordinate. So that area will be 3 minus 0, so 27, 3 cube 27 upon 6L. L is once again 1 only here, so that will be how much? I think 9 upon 2, 4.5. So if you subtract these two, you get your desired area, that is coming out to be 9. Okay, so dear all, I am sure you are getting the importance of To-Do's theorem. Otherwise you will be doing it by integration. Maybe you will be doing integration with respect to y from 0 to 3, subtracting this area function of this line from the parabola. That way it can be done definitely, but I am trying to tell you that integration can be avoided in such questions. Okay. Now one question from ellipse. We are asking maximum area of triangle inscribed in an given ellipse. Okay. So how you will find? Okay. If you do it directly for ellipse, okay, and try to use calculus, it becomes difficult. In fact, people sometimes feel that there should be some symmetry, but there is no need actually. Please see, if I find maximum area of a triangle in corresponding auxiliary circle, because for every triangle on the auxiliary circle, if you find corresponding vertex on the ellipse, okay, the area of ratio of the areas of this triangle has to be fixed, B upon A. So if we are looking for maximum area of a triangle inscribed in the ellipse, it has to be b upon a times the maximum area on the auxiliary circle. And on auxiliary circle, as you know, maximum area of a triangle is obtained when that triangle is equilateral triangle. So find that area of equilateral triangle and we are done. Now in case of auxiliary circle, suppose its radius is a, okay, we know it's equilateral triangle, so its center will be circumcenter, all centers actually, centroid, whatever center, okay. So this area can be found using the sum of these three triangles. It will be 3 times 1 upon 2 into radius into sine 120 degree. This angle will be 120 degree, that is root 3 by 2. So this becomes root 3 into 3, so 3 root 2, 3 root 3 upon 4 into a square. So that is the area of triangle of maximum area in the auxiliary circle whose radius is a. Now if you want this to be in ellipse, just multiply by b upon a. So this maximum area will become equal to how much? 3 root 3 upon 4 into ab, and that's it. Okay, let me just verify. I think that should be correct. Yeah. Okay, now I am moving to few PYQs. Okay, and I'll show you these actual questions they were asked in JEE Advanced, and how to-do's theorem or my 1/3 thing will help you to get the areas. Please see, they're asking the area of the region x comma y belongs to R square. R square means xy plane, such that y is greater than or equal to under root mod x plus 3 and this 5y less than or equal to x plus 9 less than or equal to 15 is equal to. Okay, now to solve this question, first we have to make a diagram. Okay, we have to understand what this thing would be. If I write it as y square equal to mod x plus 3, okay, so you have to take care of two things. One, your y has to be positive on the boundaries, and another thing that we have to choose that region where y will be bigger than this thing. I am keeping it equal to sign. Equal to sign can only give you the boundaries, but you have to think of greater than will be lying on which side of that boundary, that we have to think ourselves. So before I do it, y square is equal to mod x plus 3. Okay, that means y square can be x plus 3 or it can be minus of x plus 3. Don't get confused, minus x plus 3 may not be negative thing. It depends upon your value of x. Okay, so if I draw y square is equal to x plus 3, okay, this diagram would be having a right opening parabola whose vertex will be at minus 3. It will be like this. Okay, and as I told you, my y should be positive, so I am choosing only the upper half of the parabola. For y square is equal to minus x plus 3, it should be left opening parabola, vertex will be same minus 3 comma 0. So this is how these portions of parabola will be looking like. Okay, I think I have not made it. So this has to be like this. Okay, and then we have to understand, before that we need y greater than under root of mod x plus 3. That means it should be above these two half parabolas. It should be above these two half parabolas. Now then next is 5y less than or equal to x plus 9 less than or equal to 15. Now for that the boundary should be 5y equal to x plus 9. Okay, now to get the point of intersection of this portion with these two half parabolas, I think I'll put x plus 3 value. X plus 3 will be y square, so it will be y square plus 6 in one case, or in other case x plus 3 is actually minus y square, so it will be minus y square plus 6. Okay, x plus 9 is x plus 3 plus 6. So for x plus 3 I am putting y square or minus y square. Okay, now if you solve them, so for first it is y square minus 5y plus 6 equal to 0. I think we are getting two values of y, that is 2 and 3. Okay, and here if you solve, it will be y square plus 5y minus 6 equal to 0. So we are getting y is equal to 1 and I think minus 6. Yeah, okay. So here if you draw that line, if you draw this line, I think it should be like this. Y is equal to 1. So somewhere here, okay, my diagram may not be that accurate. It should be something like this. Okay, in fact let me find the x coordinates, then I think I will be able to make this diagram more with more clarity. For y is equal to 2, when this upper half of the parabola is meeting this line, if I put y is equal to 2, so my x will be, I think, 1, x will be 1, so that point has to be here, somewhere here. And if you put y is equal to 3, so 15, so x will be equal to 6 for this. Okay, so 1 comma 2 and 6 comma 3. So my line should be something like this. Okay, that point will be for that other parabola, and y coordinate is 1. If you put y is equal to 1, so we will be getting x is equal to -4. So this point is -4 comma 1. So -4 comma 1, this will be -4 comma 0 here. That point is, I think, 1 comma 2. Okay, this point will be 1 comma 0 here, and this point is 6 comma 3. So this is 6 comma 0 here. Okay, now let's try to understand which area we are actually looking for. We are looking for the area that is lying above these two halves of the parabola, and 5y less than or equal to x plus 9. So this line y, 5y equal to x plus 9 is this line, and we want the portion that is lying below it. So I think we have to look for this area. We have to look for this area only. Okay, because this small portion here that is lying above this line, so, and we are supposed to use below portion only, and also x is less than 6, so we have to be restricted before this point. So you can see after that maybe we could have got some area, which is lying above the half parabolas and lying below the straight line, but this is not allowed because we are looking for x less than or equal to 6. So this is the area which we are looking for. Okay, now how to find it? I think the best would be that you find this area of trapezium. Okay, you find the area of this trapezium and then subtract two areas that can be found using 2/3 of the rectangle, one here, because both the portion of these parabolas having this boundary along their axis, here also and here also. Now to find the area of trapezium, I think we know it is always 1/2 into sum of parallel sides into distance between the parallel sides. So parallel sides are having length 2 here, 1 here, so 3. Okay, I will be writing it trapezium, area of trapezium, I will be writing it here. So that will be 1/2 into sum of parallel sides, height 2, 1 here, so 3, into distance between the parallel side, that is 1 minus -4, so 5. So that is coming out to be, I think, 7.5 or 15/2 you can say. Okay, now to find this area which we have to subtract, the area that we are supposed to subtract, is it visible? Yeah, I think it is visible. Which area we have to subtract? Yeah, this area we have to subtract. Yeah, this and this. Okay, now to find this area, what we will be doing? We will be finding it by 2/3, 2/3, yeah, into the area of this rectangle that will be formed along axis, tangent at vertex, and from this point. So it will be -3 to 1, that is 4 one side, and other side is 2. So 4 into 2, 8. So 16/3 for this, and similarly for this, if you find the area, it will be 2/3. It will be 2/3 into the area of this rectangle here, and that will be, I think, 1 here and 1 here. So 2/3 into 1. So if you add these two, this is, I think, 16/3, that is 2/3. So 16 plus 2, 18/3. So these two areas which we are supposed to subtract is actually 6. Okay, so the final answer, so the final area, maybe I am having a next slide also. Yeah, so final answer would be, final area, you can say, it will be 7.5 minus 6, that is 1.5 or 3/2. So answer for this question is C. Okay, I think this to-do's theorem or 2/3 thing is helping a lot. Otherwise what you will be doing, you will be subtracting this linear function to subtracting your parabola from linear function, taking your limits from -4 to -3 and then -3 to 1. That way it can definitely be done, but please see, you may get confused between how to take this y equal to root of mod of x plus 3. and then you have to do the integration, you have to put the limit. Definitely it can be done, no doubt about that, but I am just giving you the idea that this to-do's theorem, 2/3, this thing is very important, very important to solve questions faster. Now one more question from PYQ 2019. The area of the region xy less than or equal to 8 and y between 1 to x square. So first we should know what is the diagram, then I think we can find the area also. So 1 is y equal to x square, y will be above x square, but also greater than 1. So greater than 1 means this will be my line y is equal to 1. So we are looking for the portion that will be lying above this y equal to 1 line, but lying below this parabola also. So maybe this region which is what we are looking for. Okay, now coming to this xy equal to 8, that means rectangular hyperbola. This point will be y is equal to 1, if you put it will be 1 comma 1. Okay, now xy equal to 8 means it will be going above this like this. Okay, in fact this point, if y is equal to 1, your x coordinate will be 8. So this is 8 comma 1, and this point, that will be the intersection of this hyperbola with y is equal to x square. So if I put y is equal to 8 by x and equal to x square, I think we are getting x equal to 2 here. So that point will be having coordinate of x coordinate to be 2, and if you put it here, your y coordinate will be 4. Now which area we are looking for, let's understand this. So we are looking for xy less than or equal to 8 means it will be below this rectangular hyperbola, so that product of xy remains less than 8. Okay, this is my x coordinate, this x axis, this is my y axis, so it will be below this thing, and also it should be above y is equal to 1, it should be below this parabola. So overall we are looking for this area, okay. So let me call this point as A, this point as B, this point as C. Okay, now there can be many ways to do this question, including integration. One integration has to be done, because I have not told you any short trick for area of rectangular hyperbola, and there is no need, because that area, that integration is not that difficult. So we don't have to remember everything. I am only asking you to remember that thing that is used frequently. So here also you will be finding area of parabola using that to-dos. Okay, so let us do one thing. A to B I am joining directly. So this small portion here, maybe I think you can see it here, I'll use a different color. So this portion I have to subtract if I consider AB as a straight line. Okay, and so I will be doing one thing, I will break it into two parts, one this and one this. Okay, so for this first portion I will find area directly, because this triangle I can find, okay, because this is 1 comma 1, this is 2 comma 4, so this will be 2 comma 1 here. So this portion here that we are looking for has to be triangle minus this small area that we will be finding by to-do's theorem. Okay, that small area should be how much, because we have to take the projection on tangent at vertex, so it will be given by difference of x coordinates, so 2 minus 1, so that is 1 cube upon 6 L, L is once again 1, so this small area is 1 upon 6. Okay, and the area of this triangle, if you have to find, I think it is half into base into height, so base is 1 and height is I think 3, so this portion would be I think 3 by 2, half base is 1, height is 3, so 3 by 2 minus 1 upon 6, so that will be how much, 3 into 3 9, 9 minus 1 8 upon 6, so it will be 2 upon 3, that is the area of this thing. Okay, please understand the boundary here was by parabola, not by straight line. That's why when I am finding the area of triangle, I am subtracting the small portion here that is between that line AB and the parabola. Small portion, but I hope you can still understand it, feel it. Now to find this area, I think I will go with integration. Here limit will be from 2 to 8, and what is the function above? I think that is 8 upon x, because that is xy is equal to 8, so 8 upon x is the upper boundary and the lower boundary is y is equal to 1. So this is what we are looking for if we are looking for this integration, this area actually. So it will be 8 ln x minus x, limit from 2 to 8. limit from 2 to 8. Okay, and if you solve it, you will be getting 8 ln, I think 4, because 8 by 2 is 4, or minus 6. Okay, that is 16 ln 2 minus 6. Okay, this is this portion, and if you add 2 by 3, I think you will get your answer. I think 6 minus 2 by 3 is, I think, 14 by 3. So 16 ln 2 minus 14 by 3 is the answer. Okay, I remember this question when this was asked in 2019. We were solving these paper. We always do this kind of practice after JEE Advanced exam. Sorry, not this question. Actually, that was previous question. Yeah, that was previous question. Yeah, that the people was making a mistake. In fact, I also made that mistake in the beginning. I was feeling that this line will be going above this parabola, and I was intersecting it at this point directly. Okay, in that case, if you will be getting a wrong answer, and these JEE people, they have given that option also there in this question. Okay, so they anticipated this kind of errors will be made by the student, and they deliberately put that answer also in this ABCD if you make this line directly here. Okay, so be careful when you are solving questions of area, in fact any chapter, because they are always after you that you make some error and you do it, you get 0, okay, or maybe minus also. Now this question of 22, here we are given a function fx as x square plus 5 by 2, and another function gx as a function 2 into 1 minus 4 times mod x by 3 and 0 for various values of x. Okay, now they are asking the area of the region once again, mod x less than or equal to 3 by 4 and y between 0 and minimum of fx comma gx. Okay, now to do this question once again we have to make the diagram, and then it will be simple. This will be this graph of fx equal to x square plus 5 by 12 has to be upward parabola. Okay, but this time at x is equal to 0, the value will be 5 by 12. It will be slightly, you know, lifted parabola you can say, but still it will be upward parabola. That is for y is equal to fx, this function. Okay, now coming to this thing, let's first make this for x positive. I think this graph should be symmetrical about y-axis because mod x is there. So for x being some positive value and same magnitude but negative value will give you same value of this function gx. So here I think if you put x is equal to 0, your value is 2, okay, and for x is equal to 3 by 4 it is 0. So this will be a graph like this. At 3 by 4 it is 0, at 0 it is 2, so 0 comma 2, and same thing will be on the right hand side also. So the area that we are looking for now is actually this one. You can see it. What area they are saying? They are saying y between 0, 0 and minimum of fx comma gx. As you can see, minimum of fx comma gx will be given by these lines or these you can say curves like this. In different domains, you can see these are the portion of minimum for fx comma gx. So this is the area we are looking for. Okay, I think I will leave this question just by telling you that here you can find the area of trapezium. First you have to find the point of intersection. I think for this point of intersection I will be solving 2 into 1 minus 4x upon 3 is equal to x square plus 5 by 12. Okay, now this you have to solve. There is no option of it. Maybe sometimes you can observe what should be this value, but if you cannot observe then you have to solve it. Okay, I think this comes out to be, x coordinate is coming out to be 1 by 2 and 1 by 2, and y coordinate is 1 by 2, so that will be 2 by 3, 2 by 3, so 1 by 3, so 2 by 3, I think 1 by 2 comma 2 by 3. Let me see if it is satisfying this also or not. So 1 by 4 plus 5 by 12, 6, 1 by 4. So 1 by 4 means it will be 3 by 12, 3 plus 5, 8 by 12. So 2 by 3, yeah, that's correct. So that is the point of intersection here, and by symmetry this will be minus half comma 2 by 3. Okay, now you can find the area of this trapezium directly, and this area that is between the parabola can be found using 2/3 thing easily. You just have to find the area of this rectangle. This rectangle you have to find, and 2/3 of it will give you this parabolic area. So find the area of trapezium, subtract 2/3 of this rectangle, and that will give you the answer. Okay. The solution of this question is also given in my session notes. Still, if you find any difficulty, you can go through there. Yeah, one more question, 2024. Here we are given xy belongs to r into r, x positive, y positive, so first quadrant. Then y square is less than 4x. Okay, so let me start making this diagram. Y square is less than 4x, means it should be below. Okay, and y square less than 12 minus 2x, so that will be some parabola like this. Okay, here this point would be 6, 0, as if you put y equal to 0, so x coming out to be 6. Okay, and if you solve these two, your point of intersection would have x coordinate to be, I think, 2. 6x is equal to 12, so that will be 2, and y coordinate will be 2√2. Okay, then they have given one straight line also, 3y plus √8x less than or equal to 5√x. If you put y is equal to 0, your x is coming out to be 5, so it will be slightly here. And if you observe, this 2, 2√2 is satisfying it. Okay, so here this line will be passing like this. Now which area we are looking for here? We are looking for the area that is lying below this parabola, because y square less than 12 minus 2x, and for this line it is less than 5√8, so that should be towards where origin is there. So we are looking for this area actually. So you can now find this area directly by doing 2/3 for this portion, and this is just a triangle. Okay, this point is 2, 0. Okay, and this is 2√2. So 2/3 of what? 2/3 of the rectangle. Which rectangle? I think this rectangle. You can see this is along axis, this is tangent at vertex, so we can definitely use that 2/3 thing. So this will be, because this is 0, 0. Okay, so I think this multiplication of 2√2 only. So 4√2 into 2/3 will be this area, and to find this area, I think you need 1/2 into base, that is 4, not 4, 5, 0 was this point. So 5 minus 2, 3. 5 minus 2 is 3. And height is 2√2. Height is 2√2, yeah, correct. So what are we getting? We are getting 8√2 upon 3. Okay, plus that will be 3√2. 3√2. So 9 plus 8, 17√2/3. 17√2/3 will be the complete area, and it is equal to alpha √2. So alpha will become 17/3. So you can get your answer from here. So once again you can see why I am repeating that to-do's theorem 2/3 thing, because of plenty of question has been asked on this. Okay. Now these two things also I will say, I'll ask you to remember for sin x and cos x. If it is just y is equal to sin x, this area between 0 to pi is 1. Same is for cos also, 0 to pi/2, cos x also it is 1. Between 0 to pi/2 for both, 0 to pi/2 sin x or 0 to pi/2 cos x, they both are 1, 1. Please remember it. In many places you may need it. There is no need to do any integration. Similarly, for ln x, if you are drawing a graph of ln x or e power x from -∞ to 0, these two areas are same. Okay, because they are inverse function of each other, and these areas are equal to 1, equal to 1. Okay, in fact when you do it for ln x, you have to find a limit. Okay, so if you are doing it in an exam, you may take slightly more time, so it is better to remember that few areas are just 1 only, like ln x, e power x, sin x, cos x, between 0 to pi/2. If it is not sin x, cos x, if it is sin of 2x, cos of 2x, then it will not be 1, 1. You have to use the scaling thing. Okay, now the last thing that I will be talking about here, it is concept of minimum area. What it is, let us see. We are given a function fx which is monotonic, that means it is increasing. Okay, and increasing in x is equal to a to x is equal to b. Okay, and area bounded by the ordinates, x is equal to a, ordinate means a line that is parallel to y axis, x is equal to a, x is equal to b, y is equal to fx, that graph itself, and y is equal to f of c. Now f of c means it will be a constant value at x is equal to c. So at x is equal to c, the value is y is equal to c. Okay. Now we are looking for the area. Try to understand. This is y is equal to f of c. This is my graph. So you can see the area is in two portions. One below this y is equal to f of c, one above y is equal to f of c. Now the sum of these two areas will be minimum if you choose C as a midpoint of A and B. That is the concept of minimum area. Okay, so this area will be minimum if C is A plus B by 2. Whether your graph function is increasing or it is decreasing, in both cases this sum of these two area will be minimum when C is the midpoint of A and B. The proof I have given in my session notes. Okay, please go through it. I have given very interesting proof, not by calculus, by observation, by visualization, that how if you increase C, if you start changing C from left to right, how this f of C will go up and your areas will be changing, and by observing that thing you will be able to conclude it has to be when this C is a midpoint. This area has to be minimum when C is the midpoint. Okay, that is one thing. The minimum area thing I have included one more place, rather you can say 2-3 more places, but they are similar, and that is, suppose you are given a variable line passing through P point. Okay, and it's making a triangle with x-axis and y-axis. Okay, P is fixed, but you may have many such lines passing through P, and you may have many such triangles. Okay, now out of these triangles, if we are looking for minimum area triangle, that will be when your P is midpoint of AB. P is midpoint of AB. Proof of this can also be done similar way as I did for this thing. Which thing? This thing, bachcho. Okay. Now, not only when it is x-axis, y-axis, if you have any two lines, let's say L1, L2, okay, they are meeting at some angle other than 90, and there is a point P, okay, and you are free to make any variable line passing through fixed point P, and you are looking for this area to be minimum. This will again happen when P is the midpoint of this AB. Okay, so the minimum thing is actually connected with something midpoint. Here also you can see C was the midpoint of A and B. Here also this variable line will give you minimum area bounded with this variable line and two x-axis, y-axis, or two lines when your P is midpoint of these, intersection of this variable line with these two given lines. In fact, if you are having a variable line and you are having a curve like conic section or e power x ln x, this kind of curve, if you are having conic section e power x ln x, then also this area will be minimum if your P is midpoint. The concept behind it is similar to what proof I have given for this thing. Please go through my session notes. If you have any problem, just let me know. Maybe I can give some methods you can understand, but I think that should be sufficient. I have given it in the session notes. Please go through it. Okay, now I'll do 2 questions based on that, and that will be the end of this session today. If area bounded by fx equal to this cubic and the straight line x is equal to 0, x is equal to 2, and x-axis is minimum, then we have to find the value of A. Okay, now you see this cubic is having its derivative x square minus 2x. So that is x into x minus 2. So between x is equal to 0 and x is equal to 2, this cubic will be decreasing function because its derivative will be negative. Okay, so that will be a decreasing function like this. Okay, now A, because A is unknown, so if you raise the value of A, your graph will go up. If you decrease the value of A, your graph will go down. Okay, but depending upon what value of A, your x-axis may be intersecting somewhere in between. So I am assuming that this is 0 here and this is 2 here. Okay, and as we have seen, this kind of area, because that's a monotonic decreasing function, this kind of area becomes minimum when this point here is the midpoint of 0 and 2. Okay, then we are done. We want at y is equal to 0, at y equal to 0, yeah, that is what point? That should be some alpha comma 0, okay, and alpha has to be equal to 1 if we want area to be minimum. That means at x is equal to 1, the value of this function should become equal to 0. That means 0 equal to 1 by 3 minus 1 plus a will give you a is equal to 2 by 3. So for this question, a has to be 2 by 3. I hope you understand it. If you do this question without this method, you can do it. First you find the area, then you do the differentiation with respect to a, and then you will be able to get that which value of a will give you the minimum value of area. But this midpoint thing, please remember midpoint, okay, will give you the minimum area. In fact, let me tell you one more thing. Some of you might be thinking that suppose this is my 0, this is 2, x is equal to 0 and x is equal to 2. Suppose my x-axis is going from here. That is also possible, because if the value of a is very high, then it is possible that x is lying below this graph entirely in the range x is equal to 0 to x is equal to 2. But I think very obvious, this cannot be minimum. I think this has to be more than this area which we are finding it here. So for minimum, first thing, that this x-axis has to intersect this graph, and second, this has to intersect at the point where it is a midpoint. Okay, one last question before I end my session. If area bounded by this quadratic parabola and the line is least, find the value of k and also the least area. Now this will be upward parabola, okay, and this line will be somewhere like this. Okay, now this line, as you can see, for various values of k will always be passing through 0, 1. If you put x is equal to 0, y value is 1. So irrespective of choice of k, my fixed point lying on this line is 0, 1. So can I say this is a line that is passing through 0, 1, and for various values of k it can be, like this, or many more possibilities. So here, to find the minimum area, I think I have already told you, this has to be the midpoint of these 2 points, A and B. Okay, now how to find k? I think if I solve these 2 curves, that means I have to equate their y values. So it will become x square plus 2x minus 3 equal to kx plus 1. Now if a and b are having their x coordinates as x1 and y1, x1 and x2, okay, then midpoint having x coordinate equal to 0 means x1 plus x2 has to be 0. In fact, x1 and x2 will be the root of this quadratic. Now sum of roots can be 0 if your linear term x terms are not there. So you can see the value of k has to be equal to 2. If you take this kx plus 1 that side and you make the coefficient of x equal to 0, because you need sum of roots to be 0, your k value is coming out to be 2. K's value is coming out to be 2, then you will have minimum area. And now they are asking the area also. Now please understand, if k is equal to 2, okay, my quadratic will be x square equal to 4. If this is 2, this x term is gone, so x will be plus minus 2. Okay, that means this point will be having x coordinate as 2, this point will be having x coordinate as minus 2. Okay, and that is all I need. Why? Because I know one very important thing, very important result, that is called to-do's theorem. Yes or no? To-do's theorem. Because for this area, if you are looking for, you just have to take the projection of AB on tangent at vertex, because it's a vertical parabola. So tangent at vertex is along or parallel to x-axis. So that projection will be just the difference of x coordinates. So 2 minus 2, 4, that will be my d. Okay, and length of latest rectum you can see by the coefficient of y and x square, that is 1. So from this we get area to be equal to d cube upon 6l. Okay, so how much? 64, that is 32 upon 3. So that will be the answer of this question. No need to do any integration, bacho. You may say I have deliberately taken those questions where to-do's theorem and other things are used, but let me tell you, here I have seen in JEE Advanced actual questions. I have shown you all these JEE Advanced actual questions where you can use this to-do's theorem. So very important, I will say, remember dq upon 6l. Wherever you are finding your parabola, try to apply it. If you are not able to, then definitely you will go with integration. No one can stop you from using it, but always try to have practice on to-do's theorem. In fact, in JEE Mains Advanced, definitely there are questions, but in Mains I have seen questions where they are direct based on to-do's theorem. Circle with parabola, parabola with straight line. Everywhere you will be using this to-do's theorem directly. Okay, so that is all for today. Thank you so much, bachcho. Bye. See you.